maximum usable frequency, that is denoted with the M of, that is, it is also called as MOF. MOF stands for maximum usable frequency. So what is meant by this maximum usable frequency? Okay, so I can write it as MOF is a limiting case, limiting frequency, which can be reflected back by, which can be reflected back to earth, but this time, for some specific angle of incidence, for some specific angle of incidence, rather than vertical incidence, rather than vertical incidence. Okay. So what is the definition for critical frequency? For if that for angle of incidence. Okay. So what is the definition for critical frequency? You are transmitting at vertical incidence. Vertical incidence means here I is equal to 0. That is in the case of critical frequency. But whereas here, maximum usable frequency. So this, that is means if I observe here, this is my ionosphere, and this is my earth surface. You are transmitting the signal vertically. Okay, you are transmitting the signal vertically. So here I is equal to 0. Okay, so you are transmitting other than vertical. Okay, so the expression is equal to sin I by sin R. Here, since the signal should come back, sin I by sin 90 degrees, that is equal to sin I. Okay, since the angle of reflection is 90 degrees. So for F is equal to F mu. Okay, mu is equal to sin. Mu is equal to sin. Therefore, so sin I is equal to root of 1 minus 81 f by f of whole square. Okay, 81 f by f of whole square. Okay, sorry. Or FC square generally, it is f c 81 f by f of whole square. Okay, so from this, sin I is equal to 1 minus 81 n by f of square. Okay, you know that the critical frequency of C is equal to the formula in node root n. Okay, so from this fc square is equal to 81 n. Okay, so in the place of 81 n, I can replace with fc square. In the place of 81 n, I can replace with fc square. So sin I is equal to 1 minus fc square by f of whole square. Okay, so let us consider fc square by from this fc square by f of whole square is equal to. So if you bring the squaring on both sides, it will become sin square I is equal to 1 minus fc square by f of whole square. So if you bring this fc square by f of whole square is equal to 1 minus sin square I is equal to cos square. So we know that sin square theta plus cos square theta is equal to 1. Therefore, critical frequency of c square by maximum usable frequency is equal to cos square is equal to cos square I. Okay. So from this, fc square is equal to cos square I. So similarly, f of whole square by fc square is equal to 1 by cos square is secant square I. Therefore, f of whole square is equal to f c square into secant square I. So therefore, finally the expression for f of is equal to f c into secant I. So very, very important relation. This gives the relationship between maximum usable frequency and critical frequency. Therefore, f of is equal to critical frequency fc into secant I. fc into secant I. Okay. So the limitation for the angular frequency is the limitation for the angle of incidence, the maximum angle of incidence is 74 degrees. Okay, therefore, F naught is equal to Fc into secant 74 degrees. So, F naught approximately equal to 3.6 Fc. 3.6 Fc. Okay, so this is one expression. Okay, so this is one expression for maximum usable frequency. Okay, let us derive another definition. Let us derive another formula for maximum usable frequency MUF. Okay, so let us consider this is my earth surface. This is the radius of the earth surface. This is also the radius of the earth surface. This is also the radius of the earth surface. This is my ionosphere. Okay. So I have transmitted some signal with some angular distance and the wave reflected back. Okay, and the wave got reflected back. Okay. So okay. So let us take this. So for example, this is my earth surface. Okay. So this is my earth surface. This is transmitting antenna. This is receiving antenna. This is the ionosphere. Okay, so the separation distance between transmitting antenna and receiving antenna is, let us consider this is D. It is D. Transmitting antenna, it is D. Let us take here, this is the angular distance D. Okay, so H is height above the earth surface. H is height above the earth surface and D is distance between transmitting antenna and receiving antenna. Okay, so let us take cos I from this cos I. What is the form of the cos I? So it is h by root of h square plus t square by 4. Okay, so h is equal to, or the adjacent cos I is equal to, this is height and distance is t by 2. Okay, so you can write it as cos I is equal to h by root of adjacent side is h square plus t square by 4. Okay, t by 2 means t square by 4. This distance is t by 2. Okay, so cos I is equal to h by. So this can be written as, so if you take the LCM, I can take it as 2h by root of 4h square plus b square. Okay, so we know that mu is equal to sin I by sin R. Here R is equal to 90 degrees. Okay, therefore fc square by f, f square of is equal to cos square I. Okay, so this is expression 2, this is expression 1. Okay, so therefore from 1 and 2, from 1 and 2, we can write it as cos I is equal to, this is the expression for cos I. Okay, cos I is equal to 2h. Okay, so this is cos I. This is cos square I. So from this expression 1, the value of cos square I. Cos square I is equal to 4h square by 4h square plus t square. Let us consider this is expression 1. This is A, expression 1, and this is expression 2. Now compare 1 and 2. Now comparing 1 and 2. Comparing 1 and 2. What is this 1? 1 is equal to cos square I is equal to 4h square by 4h square plus b square. What is 2? Cos square I is equal to fc square by f square. Therefore, fc square by f square is equal to 4h square by 4h square plus d square. Okay. So fc square by f square is equal to 1 plus 4h square by d square. Okay. So f square is equal to fc square into d by 2h whole square plus 1. Therefore, final expression for the f is f is equal to fc into root of d by 2h whole square plus 1. Very, very important. What is this d? What is this d? D is the separation distance between transmitting antenna and receiving antenna. What is this h? H is the height from above the earth surface. H is where d is distance between transmitting antenna and receiving antenna, and h is height above earth surface, height of earth surface to ionosphere. So the definition for different definitions for f is fc into root of d by 2h whole square plus 1, or the other expression is 3.6 fc. Okay, so these are the different expressions for maximum usable frequency. These are the expressions for maximum usable frequency.